Devastating wildfires.
I'm Aziz Rahimov, and I am the founder and the president of HEAT Robotics.
The project name is Ember. The purpose is to combat some of the issues we're having in the Okanagan area with fires, wildfires.
The cities of Kelowna and West Kelowna are now under a state of emergency.
It was scary, not fun at all.
I think Ember can pretty much help anywhere after a fire.
It's capable of navigating forest terrains.
We also implemented a lot of customizability.
Specifically the front module, which has a quick attach and detachment plate.
Its functions allow it to operate in various areas. And so you can see here in the front, we have a quick attachment mechanism that allows our bot to have more modularity and to attach different components that help us tackle problems beyond hotspot detection.
It has 3 basic checks in place to make sure that we're finding a hotspot. We have our FPV camera, which when it's being manually controlled, the user can then obviously see what's in front of them. And then we have a TOF, a time of flight camera, which is actually nothing about flight. It's actually about object detection. So it will tell us the AI if there's an object in front of it. And then this little thing up here is a thermal camera, and this is so that the user can find a hotspot in the distance and then go move the bot towards it to then use the rest of the sensors to double check and gather more data about that hotspot.
The way it drives is it's fundamentally 2 of the same module duplicated twice. Each tank track is individually controlled with its own outrunner motor and their direct drive, and each motor is controlled independently with the Cube flight controller. All of those motors and the controllers are then programmed using, it's called the Cube Orange Plus. It is our flight computer, and that flight computer basically sends data to those motors and drives all 4 of them.
This is the main brain of it. The AMD Kriya KR260 does all of the main computing power. Our temperature probe, which can extend downwards and into the ground to figure out how deep and how hot a hotspot is under the ground.